Here we have a 2D support reactions problem. So you can see we have this blue rectangular plate that is sitting in this U-shaped container, and the plate has 3 rollers, one at A, one at B, one at C, and then a load at D of 120 Newton. And we are asked to do that free body diagram and then find the support reactions at A, B, and C. All right, so the body that we're interested in is, of course, that plate. So let's see if I can get a rectangle here. Something like this. And we have our load up here. That was 120 Newton. And that was point D. And then what do we have? We have a roller at A that's locking or rolling along this vertical surface. So we'll have a support reaction in A that goes horizontal. So we'll call that A. B, we have a roller on a surface that is horizontal, so it is going to be vertical. B, and then at C again on a vertical surface, so it is horizontal. That'd be C. A, B, and C, and then let's do a coordinate system X, Y, and then like we can see the dimensions we'll just get from up here. All right, so that'd be our free body diagram, which means now we can go in and find our support reactions. So let's see, what do we have? Remember that the first thing you want to do is we want to see if we have maybe just a single unknown force in one direction. A and C are both horizontal, but B is the only unknown that's vertical. So let's do sum of forces in Y. Sum of forces in Y equals 0. And so we have B going in the positive Y direction, so B. And then we have minus 120 because it's pointing downward. That means B is equal to 120 Newton. All right, so that's our first one. Now again, if we do sum of forces in X direction, we'll have 2 unknowns, so it doesn't help us very much. So that means we will need to use a moment. And where should we do the moment? Well, we can do the moment at A. Then we only have B and C, or we could do it at C, and then we only have A and B. Either or is going to work. Let's do it at C. Sum of moments around C. So what do we get? If we do around C, we'd have B would be turning counterclockwise, clockwise, I'm sorry. So B minus B times, what's the distance between these 2 points? 2.2 meters. Minus B times 2.2 meters. A is also going clockwise, so minus A times, now it's the distance between A and C in the vertical direction. Well, this is 2 meters and this is 4 meters, so of course the difference between that is just 2 meters. So times 2 meters. And then we have the 120. The 120 is going to go counterclockwise, so plus 120 Newton. And now this distance is 2.3 plus 2.2, so 4.5 meters. Squeak that in there. 4.5 meters. That means I can solve all this for A. A is then, so A was negative, so all the other signs stay the same, so it'd be 120 Newton times 4.5 meters minus B, which was 120 Newton, found up there, times 2.2 meters divided by 2 meters. And that gives me 138 Newton as my A. All right, so now I have A and B, so I can just do sum of forces in the x direction is equal to 0. So I'll have A, and then C is pointing to the left, so negative. That means C is equal to A is equal to 138 Newton. And with that, I have my three unknowns, A, B, and C. Weren't any of all of our rollers, so of course there's no moments that we have to find.